Hi, this is Arif Siddiqui. Welcome to our another project that is Krigging model. We have collected some data by flying our drone in the campus, and the data contains X, Y, and Z value. So this is our works flow. At first, we import some necessary libraries and set the working directory, and then we have created a point geodata frame from the collected field data, and after that plotting the collected field data, and in this case I have actually pre-processed my image that is collected in the field by flying drone. I have georeferenced that image in QGIS, and I use that image in my plot. And after that, determining bounds for grid creation to enable interpolation or extrapolation, perform ordinary kriging to determine the optimal baryogram model using actual data. And then we have plotted all the different model baryogram bar plot, and I have chosen the spherical model bar plot for ordinary kriging, and finally plotted the predicted surface on a grid and prediction standard error. And finally I have performed the linear regression for the global plane, and I have compared with this linear regression predicted surface and Krigging surface, which is best. So let's go to our project. So this is the our necessary libraries that I have imported from the Python libraries. I have imported the operating system, NumPy, Pandas, Rastrio, GeoPandas, Matplotlib, and finally PyKrig for our Krigging model. And this is our working directory, that this is the modified image I have collected from the field, and this is I have actually georeferenced in QGIS, and this is the function I have set this function, and this is our field data, that is CSV data. Here we can see the data contains the image level X, Y, Z, and this is the accuracy of our machine, and I have made a geometry. So let I have first plotted our data on a plane surface, that is this point. We can see we have collected this data from the field. So in this actually in this plot we cannot realize what data where from where we already collected. So now I have plotted this image. So this is our field image. There have a concrete block, and this is the four corner of concrete block A, B, C, and D. And we have collected some interior data. Intentionally we collected some data in some point hole, and some of data in outside of the block. And after that actually we have gathered our geometry, that is X, Y, Z, and we have bound the data set to create the grid of size X minimum, Y minimum, X max, Y max for gridding the data. And finally we have performed ordinary kriging and selected best baryogram. We can see this is the plot of our five different model of Krigging. So here we can see that the error in the case of a spherical model is lower than all other, like linear power, Gaussian exponential. So I have chosen this spherical model as the error of physical models is comparatively lower than others. And then actually we perform this by this code the ordinary Krigging, and in this Krigging we can see the result. So there the more three important results, that is nugget. We have found our nugget is 0.07, that is very small. The range is 0.85, and the seal is 0.120 of our Krigging model. So finally, we have plotted this empirical semi-bariogram and a spherical model. We can see this red line is almost a linear line of a spherical model. As we collected some data, our elevation is not so much variable. So this red line is showing a straight line. So after that we plot this Krigging model, the predicted surface. Here we can see that in our field almost all the data almost same, except some depression we can see there. That is intentionally we have taken in the field some hole, and we have taken the point in the hole so that we can identify the Krigging is the performance of the Krigging model. Now after that we actually plotted the standard error. So this is our standard error. Actually we can see that in the whole the area is yellow, that is the yellow range is 0.35 elevation. So 0.35 means 0.35 meter. Actually, and this is the variation, not pretty bad. So finally, as per the direction, we have performed the linear regression of this model and plotted the linear regression, and it clearly seeing that in the linear regression model the plane is not uniform compared to the Krigging. So in the Krigging, most of the surface is yellow, that is the uniform distribution, but in the linearly in this side, that is the north east corner, that is we found that this prediction is very much higher, and this north east corner is very much lower. So this is not uniform. So I think this Krigging is the best with comparing to the global plane linear regression model, and by this Krigging we can evaluate the elevation in the field where we need to identify some points elevation. If I have some other points data, we can predict the any point in the site. So thank you all for watching this video.